I'm Daniel Luca. I'm a part of Consensus, so I'm an engineer at Consensus. I write code for about 14 years, and I write code in blockchain for about 2 years. Consensus, if you don't know what it is, I kind of try to describe it as the Google of Ethereum, because they do lots of stuff. They're also an incubator. They have lots of projects. They're also an investor. They also have big parts doing academy. And within Consensus, I work in Alethio, and we do blockchain analytics. Most of the time, we look at the blockchain data, and we try to find interesting stuff there, and sometimes create some kind of interesting dashboard to display some data. So what's this about? I have 2 stories. I only have 2 stories, not 30 stories or how many he had. But they're longer, and we're going to go into detail. And it really helps if you know about Ethereum, if you understand blockchain, if you're a developer, because we're going to have lots of code, and we're going to go through that code line by line. I'm going to try to make it very clear for everybody. So can you tell me if you know how blockchain works or how Bitcoin works? Can I see a show of hands? So lots of people know about Bitcoin. Do you know how Ethereum works? Because it's important to understand how it works, yeah? Okay, so a few people, but I'm still going to have a short introduction. So Bitcoin just works if you send money from A to B. And Ethereum took this technology and built a new layer on top of it. It's like an application layer. So you're able to build applications and deploy them on the blockchain. That's really cool because they live on the blockchain. That's where they exist. And everybody in the world can interact with them. An easy way to think about this is if you think about it as an API. So you create an API, you as a developer, you create an API, there are some methods that people can use, and people interact with your API. And the pretty cool thing is that your APIs can interact with each other because it's the same protocol between them. So the first story. So this is, I named this story the CryptoKitties Freelancer. Did you hear about CryptoKitties? Okay, so that's really cool. So people know about CryptoKitties. CryptoKitties is basically an application. It's a DApp. We call it a decentralized app. And you can buy kitties. You can breed kitties. So new kitties will appear on the blockchain. And you can sell some of those kitties. And it's quite cool. And this is something that made Ethereum quite popular. So the kitties can look like this. This is one really majestic kitty. This is one of my favorites. This is Sploit Cat. But most of the kitties look like this. And I want to tell you a little bit of how popular this was, because it was extremely popular at one point. It was so popular that people were playing this game on Twitch. So if you know Twitch, people go and play games there, but there were people who were just opening their browser and they were trading kitties and they were breeding kitties. And it was, that's when I understood that that's a peak that we reached. And let me see if I have a pointer. Okay. So this is a graph. It starts from block 0 of Ethereum, and it ends at block 6 million. And we did an analysis trying to understand what people interact with on the blockchain. So this is methods that people called on the blockchain on different contracts. The one in green, the one here on the top, which represent quite a bit, are the methods that are part of the CryptoKitties smart contract. And it's almost like a quarter of it, but we do ignore the ERC20 tokens. So have you heard about tokens? They are a large part of the blockchain, of what happens on the blockchain. So they actually were very popular at one point. This, as a point in time, is about December 2017. So let's understand the basic mechanic of it. You take two kitties. You have two kitties that you own. You breed them. You basically call a method that combines the two kitties. And a few blocks later, a few minutes later, you have a new kitty. And this is quite an interesting method because each kitty has a DNA attached to it. And when you combine the kitties, the DNA is combined. You don't know how exactly that is done because that was hidden. You can understand if you're fluent in assembler, but they wanted to have this hidden so people don't abuse it. The thing about Ethereum is nothing changes if there's no transaction that hits the blockchain. So let's say the first person combines the two kitties, it breeds, and then you need to wait a few blocks. If nothing happens, if there's no transaction that hatches the next kitty, if there's no party that gives birth to the new kitty, that new kitty does not exist. So somebody needs to be there, call the new function, and the third kitty will appear. In order for this to happen, because with each transaction you pay a transaction fee, you need to add a reward. So it's like you add 0.01 Ether, and the person who calls the transaction will receive that Ether minus the transaction fee. So that's why you're incentivized to give birth to the new kitty. So let's have a look at a simplified version of the breed function. So this is one function within the smart contract of CryptoKitties. We have the matron ID and we have the sire ID, which are basically the parents. It's external, it's payable, and when and you can send transactions to it when the contract is not paused. So first it checks if there's a value attached to your transaction, because that value will be saved within the smart contract until the third person comes. There are some basic checks. There's another require, like checking if the kitty is already gestating or already is giving birth to another kitty. So just some basic checks. And then it calls the breed with method. The breed with method, it emits an event and it tells you at what block you can call the give birth method, and you can hatch the third kitty. So a few minutes later, you can call the give birth method. And so this is also a simplified version of it. You get the mother of it. You just make sure that it's ready to give birth. You create the kitty, and then you send the attached reward to the person who created this transaction. Otherwise, nobody would do it. They would just pay transaction fee for nothing. And you just return the kitten ID. So you get this kitty. So when I started reading the smart contract, this was December. It was just launched. There were a few days since the contract was active, and I saw this opportunity. I saw that somebody can just create a bot and start gathering the rewards. You'll get a reward minus the transaction fee, but it always has to be positive, otherwise nobody's doing it. And I just started researching it, and I saw that somebody was already doing it. And in about 3 days, he got like $5,000 of Ether worth. So it was quite a lot of money for writing a bot and playing this game, or just extracting this ether from the blockchain. And there probably were a few more people, but one had quite a large amount of ether. So then I thought, what should I do to beat this guy? So if I want to beat this guy, I want to add a transaction with a higher gas cost. So this way, the miner will pick my transaction instead of picking his transaction, but my profit will be smaller than his. What's going to happen next? He's going to increase his transaction fee, and his profit will be smaller. And then I need to do it again, and my profit will be smaller, and so on, until like nobody wins. You get to zero like that. So I still started writing the code. It took me too much. And before I saw that, I found out there was somebody who was doing this a bit differently. So they were doing this like this. So the first part is just one transaction which generates multiple kitties. So the idea is that when you call give birth, you get one kitty. But if you create a smart contract that checks for multiple kitties and calls give birth for multiple kitties, you will get multiple kitties at the same time. And there's less overhead, so you will have a higher profit. And at least you'll beat the other guy who just does transactions one by one. And there's also another advantage if you do this. But let's have a look at like an example code of how to do this. So this is also a simplified version of how to do it. You import the kitty breeding solidity file, which is basically the interface. You initialize that. And then you use the matrons, which are like the mothers, the parameter. And for each one, you check if they are ready to give birth, and you call give birth. The cool thing is that you can check if they're ready to give birth, and then you're not creating transactions that hit nothing, that just fail. And this way, you're able to like get the reward from 10 kitties at a time, which is kind of cool. So then, okay. So if you're going to start to do this, you're going to have the same type of fight. Somebody else will create a new smart contract. They're going to increase the gas price, and you're going to have the same kind of fight. You're going to beat the first strategy, but you're not going to beat the same guy that does the same thing. So I kind of started thinking if there's a better way. And honestly, I couldn't find a better way. But after a while, I found somebody who told me a better way. Okay, so this was done by somebody at Aragon. So he was looking at the smart contract, and he was trying to figure out, he had the bundle birth, and he was trying to find out why somebody else is using less gas to give birth to multiple kitties. And he couldn't understand what was going on. And he was analyzing the assembler code, and after a few days, he found a better way to do it. And he found out that there's one thing in Ethereum that is not that known, which is refunded gas for storage clearing. So if you think about Ethereum, you're going to save data on the blockchain, but that needs to cost you. And if you're going to save lots of data, you're going to fill up the disk space of all of the nodes, and that's not what anybody wants. Otherwise, you're going to lose Ethereum like that. So another way to do it, there's another functionality within Ethereum, and if you remove code, if you remove storage, you're going to get a refund, and that's something that you can use. So I started reading the Ethereum yellow paper, specifically about refund. The yellow paper is quite dense, so if you're going to read it, it's going to take a lot of time. It's not easy to read. There are a lot of functions and notations. So it's very academic. It wasn't easy to go through it completely, but there's a simple way to explain. So if you want to save 32 bytes, you're going to use 20,000 gas to do it. If you're going to clear 32 bytes, you're going to get refunded 50,000 gas. And that's like part of how to beat the second strategy. The thing is, the refunded gas can be up to a half of your transaction cost. So it can be quite a lot. You're never going to refund it completely, but you're going to refund a lot. And if you take into consideration that the typical transaction cost for CryptoKitties is about 150,000 or 300,000, you can slice that fee in half, which is quite useful. So how they did it is they were monitoring the blockchain. So the first strategy, you just monitor the blockchain, you monitor the events, and when a new kitty can create the newer, cuter kitty, you're going to send a transaction. The second guy was doing this for a bundle. And the third guy needs to do something more, which is monitor the blockchain when the gas price is low, save a lot of data, and when you need to hatch the kitties to give birth to them, you clear data, and your transaction fee will be cheaper. And that's something that was really smart. It seemed really smart to me at that point. And I think there's another way to explain this. So if you think of systems like each physical system or engineering system, there's a potential to it. And all systems tend to have potential tend to go to the minimum potential. And when you create a transaction, it's like having this right here. So there's a potential that somebody needs to come and extract it. If they make this go at the bottom, they get that reward. They get that piece of ether. And the other guy was doing something more interesting. He was creating more potential. So it was like he was moving the ball upwards, and then he had more potential, and he was able to extract more ether in a more optimized manner. Okay, second story. Okay, so winning the lottery. There was another big application on Ethereum. It's called FOMO 3D. It's basically, some people know it. It's basically a scam. It's basically a Ponzi scheme. It's a pyramid scheme, but people still play it. And it was extremely popular. I mean, I think the pot was about 2 million in the first round. So that's quite a lot of money, but there were much more money that flowed to it. So this has like 3 basic mechanics. One is people who enter early will get dividends from people who enter late. And yeah, some of people know it. Some people probably entered the first day, and I think it lasted for a few weeks. Another mechanic is the last person who buys the ticket, the last person who enters the lottery, wins the whole pot. And there's another lesser known mechanic, which is the airdrop. So there's a chance that when you buy the ticket, you will receive some ether. There's a random chance. But random doesn't really exist on the blockchain, does it? So just a few days later, Peter Zilagi, which is the main developer of Geth, which is the official Ethereum node, he explained how people can exploit this mechanic. And it's quite brilliant. But first we need to understand how it works. So this is a simplified version. So I'm not gonna have too much code, just I think 4 more slides. So this is the basic function that you call when you buy the ticket. So it checks if it's activated, it checks if it's a human. To be a human in Ethereum, you have a wallet attached or an address. And if you also have code attached to your address, you're a smart contract. If you don't have code, you're not a smart contract, you're a human. There's another check, like if it's within the limits. And then it does some things which are not that important. I deleted a lot of code because they do quite a lot of things. And then it calls the buy core function. So what this does is it manages airdrops. It checks if you send at least 0.1 Ether. It increases the airdrop tracker. So the airdrop tracker will increase the likelihood of gaining some of the pot. And then it checks if the airdrop should be activated. So the airdrop, which is like the randomness. So there's a seed that is generated, right? And there's the Ketchak 256, which is basically SHA-256. And it uses some entropy for that. It uses the block timestamp. It uses the block difficulty. And it uses the block Coinbase, gas limit, message sender, and block number. And these kind of are things that you can use, anybody can use, because if you're within the same block, you're gonna have access to these. So that's another reason why you can't do randomness on the blockchain. I mean, nobody found a good way to do it. So it generates this seed, and it does some small computation to it. And if it's smaller than the airdrop tracker, which is always increased, it tells you that you want the pot, and you can extract that data. You can extract that Ether, the pot, basically. But there's a small problem to it. First, you need to understand that we already know that the difference between a human and a contract is the code. You have code attached to you, right? So, for example, I could write a smart contract that just copies everything, copies this, and if the conditions meet, I'm going to send the transaction, gain the pot, and if the conditions don't meet, I'm not going to do that, right? So you basically check if you're going to win the lottery before playing the lottery. The thing is, we have this, is human. So if I'm going to be a smart contract, I'm not going to be able to call this function, so I'm not going to get there. Even if I would win the lottery, I couldn't call the method. There's only one way you can do it, and it seems that the developers didn't know. Okay, so the is human is just checks the sender, gets the address code, and tells you, sorry, humans only. But if you deploy a contract within the same block and within the same transaction as the one that you're going to send, the account code is not saved yet in the storage. And that means you look like a human at that point. So that's one of the problems. There is like a proof of concept to do it. I didn't write this code. It was Peter who wrote the code. And it just initializes the FOMO interface. It copied the whole entropy and the check to see if you're going to win the lottery. And if everything is fine, it just calls the function, withdraws the funds, and self-destructs. And that's it. And you need to self-destruct to send the funds from the contract to you. Otherwise, they're stuck in the contract. Okay, so today I wrote a few smart contracts, and I wanted to show you how this looks. I think this is the best that I can do. So there's the transaction. It calls a method in a smart contract. That creates a new smart contract, because every time you need to create a new smart contract. So I created a factory of smart contracts, which was deploying a similar version of the code that you saw. That was checking inside the FOMO 3D application if I would win the lottery. And if I would win the lottery, it would play the lottery and send the funds back to me. And there's actually, this is quite interesting. It's not that complicated to do. There's a better way to do it. So what happens if you check that you're going to win, but you're not going to win? You need to wait one more block, send another transaction, and see if you're going to win then. The better way is you deploy one contract that checks if it's a winner, and if it's not a winner, you deploy another contract, and that checks if it's a winner. If it's not a winner, you deploy another one, and probably the third will be, and then you get the pot and you stop. It's basically like, you get a lotto ticket, you write the numbers down, you see if you're gonna win, you're not gonna win, you throw it away. So when I was monitoring the blockchain, there was somebody already doing this. I think that looks a bit more complicated. Could we, let's see. So you're not gonna understand much of it because it's just a bit too complicated, but he tried once, he tried twice, and he tried thrice, and then it worked. So you're gonna win the lottery every time like this, which is quite interesting. So what I wanted to leave you with is it's very important to think about how you're going to do mechanisms. You basically are going to design lots of mechanisms, lots of applications that people interact with. It's extremely important to understand the edge cases, and you're exploiting the edge cases quite a lot, and just know everything. And it's easy, right? But that makes you a better developer in other parts too. If you're going to understand these edge cases, the other parts are going to get really easy. It's like math. When you understand differentials, addition is easy, right? And it's important to create mechanisms that don't have a lot of potential energy. If you're going to have a lot of energy there, somebody's going to try to extract it. So you work with money, just be careful about the money and don't create lots of doors for that. Okay. This is where you find me. Any questions?
So in this example, you told us about how we can see if you're a winner by checking the blocks. And in this example, at the third block, it will be a winner. And to get this smart contract, we could put a code into the checker. Couldn't we just use another account, another wallet, so that that one is human, and use that instead of using this code?
Okay, you can use that, but you're not going to know if you're the winner because you need all the other parameters too. So you need the block timestamp, you need the block hash, and that changes every block. So if you create a smart contract, it already has access to all of that. And the only thing that changes is your address. So you combine a method of where you know everything and you can change one thing and you just change that entropy until you're the winner. Does it make sense? Not really? So if I'm going to be the account, I cannot run the code. I can run the code right now for the block that just happened, but I need to be in the block that is happening right now.
I think the point is you don't have enough time. Like theoretically, you can have a contract. You can have like one contract that just tells you if you're a winner and then do the transaction manually. But in reality, you don't have enough time because the new block is gonna come and that information becomes stale. So like I think that's the point.
And there are also some pieces of data like the block hash. You're not going to know the block hash. Sorry? It's the current block hash. It's the current block hash. Oh yeah, okay.
Yeah, sorry. So I have another question. You told us there are some apps on the blockchain, applications. I was wondering what are the advantages of having an application on a blockchain rather than a server or something like that?
Well, this is like an open-ended question. So I'm just going to throw at you some random words like it's trustless, it's decentralized, right? You don't need to go through banks to do stuff. The Ether already is embedded within the blockchain, within the protocol. And nobody's going to stop you to deploy a Ponzi scheme if you want. And if people really want to use it, they will use it. Nobody is the gatekeeper. And I think that's very important because at the moment we're building all these gatekeepers, which is Google, Facebook, or the United States. And I don't really like gatekeepers. I want things to be open and to have like an open market, and the market will decide the winner, not the gatekeepers. I don't want to go too much into politics right now.
Okay, thank you very much.
Other questions?
What happened in the end to the last lottery after the 2 weeks went by?
So the FOMO 3D exit scam, okay. This is how they have the domain. It's exitscam.me. So they're very aware of what they're doing. So the first round ended, and then a new round started. It wasn't as popular, but just keep the ball rolling.
Did they just kill the contract?
No, they didn't kill the contract. The contract has methods to enable a second round. And some of the funds from the previous round will get reported to the second round. So they have all these mechanisms that make you want to play again or make you want to try, like the airdrop, or don't let you stop, because if you're the last one, you can win the whole pot.
But they basically, at the end of the 2 weeks, get the pot.
It's not a specific time. It's like...
Whenever they want.
So it works like this. When you buy a new ticket, there's a timer that is increased. So people were buying lots of tickets, and there's a cap time, which is 24 hours. After a while, people didn't want to invest anymore. So they stopped buying, or they were buying less frequently. And the timer started to decrease. When it reaches 0, you're the last one. So it's not a fixed time period like 2 weeks or a month, or some people thought it would last a year. It didn't.
So the last one won the special prize, the bonus.
Yeah, I actually wanted to do 3 stories, how the guy won, because it's also very interesting, but I didn't have time to explain it. But it wasn't a bot, it was just a guy who was creating special transactions on the blockchain, and he won 2 million with that.
Ether?
$2
Or
million
dollars?
dollars in Ether.
Okay. Other questions? We still have some t-shirts. Okay. In this case, thank you, Daniel.